Hello students, my name is Shesi George, your professional accounting teacher. Please, before you continue with this video, try to subscribe to my YouTube channel, Georgian Theory Concepts. Okay, so let's get started. Now, please try to watch the part 1 of this video where I explain the concept of calculus, how to apply calculus in business, okay, before you continue with this video. All right, now, let's solve this question and apply the concept of calculus. For one type of product, it has been established that total costs in thousands is given as q raised to power 3 minus 6q raised to power 2 plus 140q plus 750. And total revenue in thousands is given as minus 0.5 q raised to power 2 plus 140q, where q is the quantity produced and sold. You are required to calculate the marginal cost and marginal revenue functions in terms of q, and hence the quantity that will maximize the profit. Then the B part says that the point elasticity of demand at the point where profits are maximized. Okay, so let's solve this question. We have solution to this question. Okay, the question says we should find the marginal costs. I told you if total cost is given to be q raised to power 3 minus 6q raised to power 2 plus 140q plus 750. All right, now if you are given the total cost and you are asked to find the marginal cost, so marginal cost will be the TC over the Q in respect of Q. Okay, so you differentiate. So let us differentiate this. So what do we have? Our marginal costs will now be let's differentiate this. So if you are given the total cost function, you differentiate the total cost function to find the marginal cost. Okay, so we have 3q raised to power 2, all right, minus 2 multiplied by this, that is 12q, okay, plus this is 1 minus 1 raised to power 0, 1 times this, 140. All right, so that is the marginal cost function. That's the marginal cost function. All right, that's the marginal cost function. Now we have answered that the marginal cost. What of the marginal revenue? If the total revenue is given as minus 7.5 q raised to power 2 plus 1400q. Okay, our marginal revenue. So if you are given the total revenue function, don't forget, and you are asked to look for marginal revenue, all you need to do is to differentiate to get the marginal revenue. I told you, when you are given the total revenue and you are asked to look for marginal revenue, you will differentiate this function. All right, so how do you differentiate? You minus 1, you reduce the power of q. So this will be the TR in respect to q. All right, so let us differentiate this. So when you differentiate this, our marginal revenue becomes you first multiply this by 2, which is minus 15q. Okay, then this will give you plus, this is 1 raised to power 1 minus 1 0, so 1400. All right, hello class, so take note of that. All right, now the marginal revenue and the marginal cost function has been determined, which is these two. Then we are asked to, they said hence the quantity that will maximize the profit. So take note, Profit is maximized. So we can just say profit. We know that profit is maximized. Is maximized. Is maximized where at the point where marginal cost equals to marginal revenue. So take note of that. Profit is maximized where marginal cost equals to what? Marginal revenue. So what is our marginal cost? It's nothing but 3q squared minus 12q plus 140 then equals to what is the marginal revenue? The marginal revenue is 15 minus 15q plus 1,4. Okay, you bring these equations together. If you bring the equation together, what do you have? 3q squared minus 12q. Then this will be plus 15q. Okay. Then what do you have? Plus 140 minus 140 equals to 0. Okay, this will lead us to quadratic equation. So we have 3q squared, 12q plus 15q. 12q plus 15q will give you plus 3q. Okay, plus 3q. Then minus plus 140 minus this minus 1,4 will give you minus 1 to 60 equals to 0. So we need to solve this quadratically. So by using the almighty formula, so q equals to minus b. This is our b, this is our a, and this is our c. Okay, so what do you have? We have minus 3 plus or minus the square roots of 3 squared. This is almighty formula. Minus 4 into brackets a, which is 3, close the bracket, open bracket again, minus 126. All right, minus 1260 all over 2 into bracket 3. Okay, at the end of the day, our q, so you can solve this quadratically. Are you with me? Students should solve quadratically. You are going to have two functions there, two answers here, which are q equals to 20 or minus 21. Since q will not be equals to negative number, okay? Therefore, our q is 20. So this is the quantity where profit will be maximized. Hence, profit will be maximized at q equals to what? 20 units. Okay, at q, profit will be maximized at q equals to 20 units. All right, class. Okay, now the B part of the question says the point elastic of demand at the point where profits are maximized. The elasticity of demand at the point where, now to calculate the elasticity of demand, okay, you have to differentiate the demand function P. And P is total revenue divided by quantity. So to find the P, the price, that's demand function from total revenue, you divide by the total quantity, okay, to find P. So because we know that our total revenue is a function of price, Q, and this now is what we want to look for. So to look for this, you make P the subject of the formula. Are you with me? So in this case, our total revenue function, so P, what is our total revenue function? The total revenue function is given as minus minus 7.5q. So minus 7.5q raised to power 2 plus 1400 q, then divided by the quantity. Okay, divided by the quantity. So if you manipulate this, our price will be this divided by this will be minus 7.5 q raised to power 2 all over q plus 1400 q all over q. So when you cut, then q here we have 1. So our p will be minus 7.5 q plus 14. So this is our demand function. And don't forget, like I told you, when you are given the total cost function, if you want to find the marginal revenue function, you will differentiate the total cost to find the marginal revenue. The same thing for total revenue to find the the total cost to find the marginal cost. You differentiate. Now to find the total revenue, to find the marginal revenue given the total revenue, you will differentiate. Okay, the same thing if you are given the demand function and you have to find the elasticity of demand, the price elasticity of demand. What do? You differentiate. So our price elasticity of demand is the P, the Q, the P, the Q. You are going to differentiate the demand function. So this is the demand function. This is the demand function. Okay, demand function. All right. So let's differentiate this. So to differentiate this will be price elasticity of demand will now be minus 7.5. This is 1 raised to power, that is 0. Then the what was it called? The price the differentiation of the differentiation of a constant is what? Is 0. So our answer is minus 7.5. Minus 7.5. Okay, minus 7.5. So that is the price elasticity of demand. So the question says we should look for the point elasticity of demand at the point where profit is maximized. At the point where profit is maximized. Okay, so at that point where profit is maximized, so this is the elasticity of demand.